All right, let's dive into the fascinating science behind auroras, those mesmerizing natural light displays that have captured the imagination of people for centuries. To truly understand auroras, we need to explore the role of solar particles and Earth's magnetic field in creating these spectacular phenomena. So what causes auroras? The process actually begins on the sun. The sun emits charged particles, mostly electrons and protons, which make up the solar wind. This solar wind constantly streams toward Earth at speeds of around 400 kilometers per second. When these charged particles reach our planet, they interact with Earth's magnetic field. Now, Earth's magnetic field is crucial in protecting us from solar wind and other harmful cosmic radiation. It's generated by the motion of molten iron and other metals deep within our planet's core. This magnetic field extends far into space, creating a protective shield known as the magnetosphere. As the solar wind approaches Earth, it can distort the magnetosphere, causing the charged particles to spiral down the magnetic field lines towards the poles. When these solar particles collide with the gases in our upper atmosphere, they transfer energy to the atoms and molecules in the atmosphere. This energy excites the atoms and molecules, causing them to emit light. And voila! After, we have an aurora. The most common type of aurora is a greenish-yellow color, which is produced by oxygen atoms. However, other colors and shapes can be seen depending on the altitude and type of gas involved in the interaction, which we'll discuss further in the next section. In summary, auroras are the result of solar particles interacting with Earth's magnetic field and upper atmosphere. This interaction excites atmospheric atoms and molecules, causing them to emit light and create the dazzling natural displays we know as auroras. Now that we've covered the science behind auroras, let's explore the different types of these fantastic light displays. So you may have heard of the Aurora Borealis, also known as the Northern Lights, and the Aurora Australis, or the Southern Lights. These two types of auroras occur in the polar regions and are named based on their geographic locations. The Aurora Borealis is visible in the northern hemisphere, primarily in the polar regions around the Arctic Circle. This includes countries like Canada, Norway, Sweden, Finland, and Russia. Similarly, the Aurora Australis occurs in the southern hemisphere, mainly around the Antarctic Circle, and can be seen in countries such as New Zealand, Australia, Argentina, and Chile. Both the Aurora Borealis and Aurora Australis share similar characteristics, as they are both caused by the interaction between solar particles and Earth's magnetic field. However, the specific atmospheric conditions and magnetic field variations at each pole can result in some differences in their appearance. For example, the colors and shapes of the northern lights and southern lights can vary depending on the type of gas and altitude of the interaction, as we'll discuss further in the next section. Additionally, the best time to observe these auroras can differ based on factors such as the time of year, solar activity, and local weather conditions. In summary, the Aurora Borealis and Aurora Australis are two types of auroras that occur in the polar regions of Earth. They share similar characteristics, but can have some differences in appearance due to atmospheric conditions and magnetic field variations at each pole. Now, let's move on to learning about the various colors and shapes of auroras and the factors influencing them. Let's delve into the captivating world of aurora colors and shapes. You might be wondering why auroras come in a variety of colors and shapes. Well, it all comes down to the type of gas involved in the interaction and the altitude at which it takes place. The colors of an aurora depend on which gas particles the solar particles collide with in Earth's atmosphere. The two main gases responsible for aurora colors are oxygen and nitrogen. Oxygen emits greenish-yellow or red light, while nitrogen produces blue or purple light. Altitude plays a significant role in determining the color of the aurora. When solar particles interact with oxygen at altitudes between 100 and 200 kilometers, they emit the most common greenish-yellow light. However, at higher altitudes, above 200 kilometers, oxygen produces a rarer red color. When solar particles collide with nitrogen at lower altitudes, around 100 kilometers or less, they generate blue light. If the interaction occurs at higher altitudes, nitrogen emits a purple hue. Auroras also come in a variety of shapes, such as arcs, bands, curtains, and corona. Arcs are curved, elongated shapes that stretch across the sky, while bands are similar to arcs that have distinct, wavy structures. Curtains are vertical undulating shapes that resemble drapes, and the corona is a stunning radial pattern that appears to converge at a single point in the sky. The shapes of auroras are influenced by the Earth's magnetic field. As solar particles spiral down the magnetic field lines, they create different formations based on how the lines are arranged. And this results in the diverse and beautiful shapes we observe when admiring an aurora. So, in a nutshell, the colors and shapes of auroras are determined by the type of gas involved in the interaction and the altitude at which it occurs. Oxygen and nitrogen are responsible for the various hues, while the arrangement of Earth's magnetic field lines influences the array of shapes seen in these mesmerizing light displays. Now that we have a deeper understanding of auroras, you might be wondering where and when you can witness these breathtaking displays for yourself. Let's investigate the best locations and times of year to observe auroras, as well as the factors that influence their visibility. Auroras are most commonly seen near the polar regions, as we mentioned earlier when discussing the Aurora Borealis and Aurora Australis. So the best locations to spot these natural light displays are typically in countries close to the Arctic and Antarctic circles. Some of the top destinations for aurora hunting include Norway, Sweden, Finland, Iceland, Canada, Alaska, New Zealand, and Australia. The visibility of auroras is influenced by several factors, including the time of year, solar activity, and local weather conditions. Generally, the best time to observe auroras is during the winter months, when the nights can be longest and darkest. In the northern hemisphere, this period typically spans from September to April, while in the southern hemisphere, it ranges from March to September. Solar activity also plays a crucial role in aurora visibility. Auroras are more likely to occur during periods of increased solar activity, known as solar maximums. These cycles, which last approximately 11 years, see an increase in solar flares, coronal mass ejections, and other solar phenomena that can boost the intensity of auroras. Local weather conditions can greatly impact aurora visibility as well. Clear skies with minimal cloud cover are ideal for observing these light shows. Additionally, it's best to seek out locations far away from city lights and light pollution, as these can obstruct the view of the night sky and make it difficult to see auroras. In summary, the best locations and times of year to observe auroras are near the polar regions during the winter months when nights are long and dark. Visibility is influenced by factors such as solar activity and local weather conditions. To maximize your chances of witnessing these dazzling displays, aim for clear skies and minimal light pollution. Happy aurora hunting! Finally, let's take a moment to appreciate the cultural and historical significance of auroras. These dazzling natural light displays have captivated human beings for thousands of years, leaving a lasting impact on our myths, legends, and art. Across different cultures and time periods, auroras have been interpreted in various ways. For instance, in Norse mythology, the aurora was believed to be the Bifrost Bridge, a glowing, rainbow-colored bridge connecting the realm of the gods, Asgard, to the realm of humans. In Finnish folklore, the aurora was associated with the fire fox, a magical creature that was thought to run through the sky, creating the northern lights with its bushy tail. Indigenous cultures around the world have also developed their own interpretations of auroras. The Inuit people of North America believed that the lights were the spirits of their ancestors, dancing in the sky. Similarly, the Aboriginal people of Australia viewed the southern lights as a manifestation of their ancestors' spirits who were communicating with the living. Auroras have not only inspired myths and legends, but have also been the subject of various forms of art throughout history. From traditional paintings to contemporary photography, artists have long been fascinated by the ethereal beauty of these natural light displays. Even in literature, auroras have been described and romanticized, capturing the imagination of readers across generations. In conclusion, auroras hold a special place in human history, transcending cultural and geographical boundaries. They have inspired countless myths, legends, and artistic expressions, reflecting our innate fascination with the wonders of the natural world. As we continue to learn more about the science behind auroras, their cultural and historical significance still captivates and unites us in our shared awe of these mesmerizing celestial displays.